All right, ladies and gentlemen, we're going to also look today at tables and Riemann sums and trapezoidal sums using tables. So, what's nice about tables that is good is that actually the widths are kind of given to you, the numbers are computed for you, and you just have to kind of use the concept. So, it says we got a left Riemann sum. So, what that means is that when we're starting the intervals, we are starting on the left side of the table. So our first interval goes from 3 to 5. Our second interval goes from 5 to 7. And then our third interval goes from 7 to 8. And I like to just put in my W's, my widths. So my first two widths are 2. And then my last width is 1. And we are going to be choosing the left side of each interval. So I'll even just get like a different color here. So between 3 and 5, I'm going to choose the 7, the 5, and the f of 7, the f of 3, the f of 5, and the f of 7. All right, so now I'm just going to kind of set up a Riemann sum. And what I like to do is I actually just like to immediately just write down the formulas. So I'm just going to say f of 3 times 2. That's my first rectangle. The second rectangle is going to be f of 5 times 2. And then the third rectangle is going to be f of 7 times 1. So it turns out that f of 3 is 7 times 2. Now, if you're at the point where you're reading these tables pretty well, you can actually just kind of use the left and kind of reason and say, okay, my leftmost number is 3 for my x. Its y value is 7. So 7 is going to give me the height of a rectangle and the width is 2. So if you're kind of down to this step almost mentally, you can do that and get away with it. But I will say that if you are writing this like on an AP calculus exam, extended response question, they really do like kind of seeing, that initial setup that we did. And some of your college calculus professors may like that too. All right, and then we have f of 7, which is 22 times 1. And then we just go forth and compute each area. This is going to be 14. This is going to be 24. And that's going to be 22. So let's see. Let's do a little bit of mental math here. It's going to be 46 plus 14. That gets me to 60. And you can see that they kind of did the exact same setup as well, using the 3, the 5, and the 7 to dictate what the y values are, and then thinking intentionally about the width. Let's look at another type of Riemann sum. Actually, let's just go and look at a midpoint Riemann sum. All right, so this says selected values of f of x are shown in the table below. What is the midpoint Riemann sum from 1 to 13 using 4 subintervals? So you have to use 4 intervals as indicated by the table. And it kind of makes sense to just divide this table into 4 even pieces. And this really lends itself nicely to the midpoint. obviously the middle one is going to get you to midpoint. I like to think about my widths. So going from 1 to 4, on my first one, the width is 3. Going from 4 to 7, the width is 3. From 7 to 10, the width is 3. So we are, pretty consistently 3. So I'm going to do f of 2.5 times 3 plus f of 5.5 times 3 plus f of 8.5 times 3 plus f of 11.5 times 3. And then I'm just going to actually put in one thing that you could actually do as just a shortcut, since the widths are all the same. What some people like to do is they just like to pull out the 3. So then you're just going to add f of 2.5 plus f of 5.5 plus f of 8.5 plus f of 11.5. And they just kind of distribute that 3, or, just kind of add in the parentheses. So we're going to do 14 plus 21 plus 28 plus 43. And this one we may actually just want to go to our calculator and see what we are dealing with. So I have 3 times 14 plus 21 plus 28 plus 43. And that gets me 318. So you can just let your calculator just take care of it after you kind of have that initial setup. All right, the last one that we will do is the trapezoid example. So we need to use 4 subintervals. And I like to kind of do trapezoids a little differently than some people. Some people just kind of write it out, from the side. But I really like to kind of do like one trapezoid at a time. So I still take my widths. So let's see, this W is 2. I got W equals 1. W equals 4. W equals 1. So my first trapezoid is going to be 1/2 times 2. And I'm just going to use the 22 plus 19. And then I'm going to do my second trapezoid. So that's going to be 1/2 times 1. And that's going to be 19 plus 14. And then I have 1/2 times 4. And that's going to be 14 plus 3. And then on this last one, it's going to be 1/2 times 1 times 3 plus 1. And we're just going to kind of like add those up. So what people like to do is they kind of just like to do it one at a time for these trapezoids. So let's see, 1/2 of 2 is just 1. And I got 22 plus 19. So that's going to be 41 for the first trapezoid. Then I have 19 plus 14. That's going to be 33. 1/2 of 33 is going to be 16.5. Then I have 1/2 of 4, which is 2. 2 times 17 is going to be 34. And then I have half of 4, which is just 2. And then I'm just going to add them up. I got 41, 16 and a half, 34, and 2. And I can get what that adds up to. I'll just use Mr. Calculator to kind of make our life a little bit easier. In fact, I could even show you how to just enter in your calculator. So we're just going to do 1/2 times 2 times 22 plus 19. And then I'm just going to do 1/2 times 1 times 19 plus 14. And I'm going to have 1/2 times 4 times 14 plus 3. And then I'm going to have 1/2 times 1 times 3 plus 1. And that's going to get me to 93 and a half. So it is all right, you know, if you have Mr. Calculator. What I care about is how you are setting up the Riemann sums. And there we have it. So we will stop with just the tables and the graphs for now. And then next time we'll get into sort of those algebraic Riemann sums.